Okay, then I'm very pleased to introduce the last presenter of our symposium, Igor Kontorovich. Igor Kontorovich studied at the Israel Institute of Technology and received his PhD there in 2013. Afterwards, he was a postdoc at Simon Fraser University in Canada before he moved to the University of Auckland in New Zealand in 2018 as an assistant professor. His widely cited articles on problem posing with particular focus on problem posers for mathematics competitions are always a great source of helpful insights for the field and help for me to get a better understanding for this activity. And we really look forward for your talk on where mathematics competition problems come from. 40 minutes are available for the lecture as well as a subsequent discussion.
Thank you so much, Lucas. Let me share my screen. You can see it now, right?
Yes.
Good to see you all. I assume that this is a good evening for most of you. It is a very good morning to me from Auckland. It's 7:20 here, so AM, and I'm practically talking with many of you from the future. This could be a nice complement to the talk of Rosa in the sense of looking at mathematics competitions and problem posing from the perspective of those who factually create them. So let me start with something which was a trigger for me to look at this direction in the first place. This is the problem that I encountered at the very beginning of my PhD under the supervision of Dr. Boris Koichu. And I will just give you maybe half a minute, not to solve it, but to appreciate this problem, please. When I saw it, it moved me. It did something for me. I was looking at that and I was wondering, how come that I've been playing with Euclidean geometry and with triangles and medians and altitudes for so many years, and I saw so many problems of this sort of type, and it never occurred to me that we can think of situations when medians and altitudes are equal to each other. Somehow, I always encountered a situation when one median was somehow related to another median, and I never had a thought that they could be compared between them. And I was a bit jealous of a person who actually thought about this idea before me. So this was my trigger for thinking about people who come up with problems of this kind for mathematics competitions. So luckily, I'm not the only one, and we can think about a range of reasons for which a mathematics education community might be interested in professional problem posers. The literature often goes back to Einstein, who said that the formulation of an interesting problem is often more important than its solution. When we look at some classical and maybe seminal papers in the field, so we see that the most visible advocates for problem posing were great problem posers themselves, Jeremy Kilpatrick and Marion Walter and others. Overall, in math education, there is a tradition that we like to look, or at least many mathematics educators like to look at how particular practices occur in the professional mathematics communities, and they try to recreate, at least partially, at least to some extent, some sort of analogs to these practices in the classroom. And there is this saying that factually says that if we choose to focus instruction on professional mathematical practice, then it is crucial to have a thorough understanding of this practice in the first place. So who might be considered professional problem posers? The answer is lies in the theoretical perspective that one chooses. I stick with the socio-cultural approach, and I look at professionalism or expertise as something which is based in professional communities and social recognition of people. Through this lens, we could look at mathematicians who pose problems as part of their research. We can think about school teachers who create problems as part of their instruction for their purposes. We can think about developers of educational materials and assessments. I'm going to stick with experienced problem posers for mathematics competitions. Well, I didn't know that this will be the title of this conference when I chose this topic for my PhD. That was quite lucky. But it is quite a fascinating cohort of people, if you think about that, because their challenge is quite unique. On the one hand, we all know that students and teachers prepare their students for mathematics competitions. So the people who come up with problems, they need to be aware of that, and they need to account for that when they create something which is supposed to be new and complex and interesting and intriguing for people who search all over the internet in preparation for this thing. On the other hand, experienced problem posers for mathematics competitions can really not know for sure who will come this time. So they practically are working with people that they're not fully aware what is their mathematical background in preparation in many cases. And still, they need to create a fascinating mathematical experience for all of them. Luckily, we know a bit about problem posing for mathematics competitions from the self-reflections that many of these posers like to share within the community. There are not many publications of this sort. I'm not going to go into depth, but just to give you maybe a taste of what they talk about. So Kilpatrick, in his seminal paper, talked about close connections between problem solving and problem posing. And he was talking about modeling real life situations. Sharygin, which is well known usually for people from the post-Soviet regions, provides specific techniques for growing new problems from familiar ones. Avital and Lebeskin talk about advanced mathematics. We can think about that as university mathematics practically, as a source for mathematics competition problems for school students. And there is a quite famous paper from Walter who practically talks about generating problems almost from anything. And when I wanted to explore this phenomenon of posing problems, I decided to go with a theoretical perspective of noticing, and specifically with John Mason's approach to it. So I will review it quickly. Mason says that at the heart of all practice lies noticing an opportunity to act appropriately. He maintains that noticing is responsible for distinguishing some things from their surrounding and bringing them to the level of awareness. And it's impossible to act on something without this something being noticed. So in this sense, we never act, we react to something that we sense. He also says that ordinary noticing, the one that happens to us effortlessly, happens to a person. We just experience it. We do not necessarily drive it. And noticing comes hand in hand with external impulses that draw attention by striking a chord with past experiences. So this is more or less what I described to you in my little story at the beginning. this perspective led me to the focal construct that I'm going to use in this talk. And this is a construct of a trigger. So I will call a trigger something which is an instance of noticing, where external impulse draws a person's attention and triggers off processes through appealing to their affect emotional domain. The examples will come in a minute, but I just want to clarify in which sense I'm going to say that something is a problem-posing trigger. I'm going to use this problem-posing as an adjective in a post-factum sense, in the sense that the processes that were triggered, they yielded the construction of a mathematical problem. This is not to say that once an impulse appeared, then this person immediately had a goal of posing a process, of posing a problem. We will see examples of that. So I was driven by the question, what are problem-posing triggers of experienced problem posers for mathematics competitions? This is a list of countries in which my participants resided. There were 26 participants in total. You are welcome to see if you recognize your country or you recognize all the countries. And maybe you even know someone who participated in this study, or maybe you participated. I think Jerry and I had a conversation about that for sure when he was at Technion at some point. The list, of course, is not representative of all the participants, and there is a clear bias towards, I would say, European region. In terms of the competitions, so these maybe are the most familiar ones: Baltic Way, Kangaroo, Tournament of Towns, a range of national and regional mathematics competitions. Experience-wise, average experience of the participants was 25 years, and it ranged from 7 to 37 years, some sort of involvements with mathematics competition. How I actually did it, participants emailed some of their past problems to me in advance. It allowed me to prepare more focused questions. Then we conducted semi-structured interviews around the creation of selected problems, the stories of which they remembered the most. From these interviews, I solicited stories of creation. I converted it into stories of creation. I sent them for the member check by the participants, made some revisions, and then there was a thematic analysis of these stories. So what I practically want to share with you is the 3 types of problem-posing triggers that emerged from this study. And broadly speaking, I labeled them as being disturbed by an unfamiliar mathematical impulse in the area of specialization, abstracting a mathematical phenomenon from an everyday life activity, and being asked to pose a problem here and now. So let's go one by one. So this is the first type of trigger, and it relates to my participants telling me that as part of the mathematics competition movement, yes, they created problems, but they did many things. They were involved in many activities that just are typical to this movement. So for example, many of them talked about going to various websites and web forums that have something to do with math competitions and solving problems and participating and posting responses. Many talked about participation in mathematics competition committees when problems need to be chosen for the competition. Many of them participated in mathematical circles that they led for the students in preparation for a competition. Many of them talked about research. Not all of them were mathematicians. I think 7 were working in the academy in STEM fields, but most of my participants had either a master or a PhD degree, and they were talking about this period when they were doing research that has to do with mathematics. And of course, they were talking about engaging with mathematics competition literature. So the numbers that you see on the right, it's the number of participants out of 26 that mentioned that they engage in these activities regularly, and they provided me with at least one problem that they said came out of these activities that I called activities that are replete with mathematics impulses. I think it's a time for an example, right? Before that, interestingly, each participant associated themselves with particular areas of specialization within competition mathematics. I'm sure that these areas will not surprise you. Number theory, algebra, trigonometry, combinatorics, plane, solid geometries. Some participants were more concrete, more specific, I would say. For example, someone talked about algebraic inequalities. This was his area of specialization. But the interesting part is that most of them talked about them specializing in just two areas to position themselves in a single area, and only one person talked about three areas. So we see that they saw their professionalism in some things and not in the others. So here is an example of a story. I will read it with you. That comes from one of my participants who is specializing in geometry, Euclidean geometry. And he says, I participated in several Olympiad committees and pay attention to similar problems that I never thought about before. All of them focused on special triangles in which three of their special segments, medians, bisectors, and heights, were equal. I became interested, but also slightly upset with myself for not considering this case beforehand. I also noticed that in all these problems, two segments were of the same kind, for instance, two height and a median, or two bisectors and a height. It gave me an idea. What will happen if a median equals to a bisector and to one of the heights in a triangle? Looks familiar, right? So this is the story of the problem that I shared at the beginning. It is quite similar to what I shared from my experience. But what I want to draw your attention to is to all these markers of what I call affective resonance. So this poser talks about becoming interested in this type of problem that he noticed, slightly upset with myself, gave me an idea. So again, this aspect about curiosity. So if I want to generalize a bit this sort of trigger, so this is a kind of schematic simplification of that emerged from the experience. All of them were talking about an activity which was replete with competition mathematics, participating in the mathematics competition committee, reading literature, and then some sort of external impulse which was within their mathematical specialization came across. So this is why I position that as intersection. And this impulse creates an affective resonance, something that makes them move, something that makes them explore, which practically leads to what I call investigative reaction to this affect and reaction to this impulse. In many cases, these impulses that they discussed, they somehow were surprising to them. Somehow they maybe took them out of their zone of specialization. There is something that I think that I specialize in and I don't know. I need to explore what's going on there. So this is one. The second trigger pertains to abstracting mathematical phenomenon from everyday life activities that I'm going to illustrate in a moment. This trigger emerged from stories in which the posers were involved themselves, and the activities were different in the sense that they were very routine, at least for them, or they presented them as routine. Let me give you an example. When we were children, My little brother came to me once with 4 apples on a plate. I wasn't courteous and took the biggest apple. My brother took the second biggest apple and finished eating it before I finished with my apple. Then he took the third biggest apple. Only then I paid attention that the last apple was very small and the overall mass of my apples was smaller than the mass of his ones. This was quite annoying because I was the one to choose the first apple, so I could choose differently. Then a question arose. I had the right to choose first, but the natural choice of the biggest apple was a mistake. Which apple should I have taken to maximize my portion? What fascinates me about this story, and actually all the stories that I collected, please notice the amount of details. This is quite impressive, I think. And when I was talking to this poser, he was in his 60s. And notice how detailed his recall is of something that happened so many years ago. It might look special, but when we look at other examples of stories from this associated with this trigger, so there are some similarities. So here are some additional examples. For example, planning the shortest driving path between multiple destinations, or detecting the right key on a bunch in the minimal number of trials, opening a tap to fill a bathtub in a way that will take an exact amount of time that it takes them to make a cup of coffee. So the similar characteristic that I noticed about these stories was maybe 2. First, they invite some sort of optimization of mathematics can be applied there to make them a bit more efficient. And the second one is that the kind of first attempt or first trial or first intuitive thought that my participants had when being involved in these stories was kind of wrong. So this can explain, again, these affective markers of what they experienced. They paid attention, they were quite upset, they could make a different choice. So we are getting back to this idea of everyday life activity, external impulse that creates an affective resonance and invites investigative reaction that turns into a problem eventually. 2 remarks on this regard. First, when I say investigative reaction, it doesn't mean that it happened immediately. So in many cases, these sort of stories was stored for many years and they were used later. Second, some people may see a relation of this type of trigger to modeling. Well, maybe there is, but not in the easy sense, because no one of my participants talk about using mathematics to model the specific situation in which they were. They were practically generalizing the situation to create a more general problem. So for example, with the Apple problem, this poser created a game where there are 2 players and there are n apples of different weights, and the challenge is more or less the same. Last trigger. So this one, I called it posing problem here and now. And it relates to situations where an organizing committee for mathematics competition realizes that it needs a problem of a particular type here and now. And they turn either to one of its members or to someone who relates to a competition and is renowned for their specialization in the particular area. And they ask them to pose a problem with having these specific features in mind. What was interesting about that there was a unanimous dislike to this type of trigger. People talk about hard work and even suffering when posing problems of this type. Several participants stated that they are incapable of posing in this way. Here are some quotes. The problem needs to come from being interested in something. The worst approach to posing a problem is to wish to pose it. here is someone else who explained his refusal when he gets invites to pose here and now. Not because I don't want to give a hand, but because I have spent too many years with Olympiads to know that I simply can't come with something decent. And this idea of referring to problems that eventually came out of posing them here and now as not being of a good quality is a theme that reoccurred in the data. And one of the participants even talked about this problem as something that elevates the quality of the set of problems that go to mathematics competitions, but the problem itself is not of a very high quality. So let me offer 3 lessons that at least I learned from this study. So first of all, regards the limitations of self-reflections of experienced posers. And I'm sure that many of you are posing problems as part of your mathematical doings, so maybe you will relate. I still believe that self-reflections can be very insightful, but they are far from exhaustive. And it's easy to leave out key aspects of a triggering process and leave them unarticulated. And if I go back to the famous saying of Walter, then yes, I would say probably, or at least hypothetically, it might be possible to generate a problem almost from anything. But what at least this study showed is that not everything creates a special affective bond between an external impulse and a particular person to whom this impulse happened. And Mason talks about that in terms of expert sensitivity. To notice certain things is integrated into their professional functioning, so that all they are aware of is a possibility to act, but not necessarily of the distinctions which trigger that act. So I would think that this relates to this idea of affective bond. Second lesson. So some similarities between these 3 triggers and educational research on problem posing. So here are some good news. The 3 triggers that I was talking about, they bear resemblance to the what has been talked in the problem posing literature. So the first and the second one bear resemblance to a didactical approach to problem posing, and Boris was talking about that yesterday, and Rosa was mentioning that today a bit as well. When the third trigger about posing here and now appears as an analog to the didactical approach, free problem posing, where learners are asked to generate a problem from a given, contrived, or a naturalistic situation. Okay. Now, the participants' preference to the 2 former triggers, it aligns with the educational talk about the potential of a didactical problem posing. Nice. And the reluctance about the third triggers, it also echoes with the common finding on students and teachers not being interested in problems they posed as a response to a task. Sometimes the educational literature, when they get the finding that posers, learners, are not interested in their problems, they treat it as a deficiency that needs to be addressed. But with this study, it allows me to interpret it as actually an expert-like behavior, not to like problems that emerged as a response to an adverse problem-posing trigger. So I think that this change of perspective could be interesting, and apparently we can behave like experts, not only when we do something, but also when we don't do something. And the last point. So should students be simply offered different problem posing tasks? So Well, this is not exactly what I would conclude from this study, because if we look in the first triggers, the first and the second one, the participants were in a position to experience an affective resonance and decide to pursue it. Problem posing seemed to happen to them. This is not exactly the approach that seems to be driven by a particular task which is imposed by some sort of external authority. And going back to Murray and Walter, problem posing becomes second nature after you do it for a while. I seem to look at the world through problem posing colored glasses. So if we want to try to talk about practical implication for teaching through or with or towards problem posing, maybe the two questions to raise is how can students and teachers be assisted to turn problem posing into second nature? But before that, it might be worth discussing whether this goal of change of nature it should be pursued, because I think that the answer has to do a lot with our mathematical and educational ideology. Thank you.